So often percentages are used to help make the size of different parts of the whole easier to compare. So I'm going to look at this table here. So this is births and birth rates by age of the mother. So here's the different age of the mother, and here's the total number of births, and here's the number for each age group, and here is the rate. Now this rate is not per 100, it's per 1,000, right? So this means 62.5 births per 1,000 women of all ages. Birth rate ages, not 6-year-olds and not 60-year-olds. So this would mean here there was 22.3 births for every 1,000 women aged 15 to 19. Well, what we're going to do is look at the percentages here. So what percent of births were from 10 to 14-year-olds? What percent of births were from 30 to 34-year-olds? So we're going to make these into percentages, part to total women of childbearing years. So here would be 10 to 14. This is a pie chart because all the births were between women 10 to 54. Now there may have been one that was 9 and one that was 55, but this covers about all of them. You can see that the highest percentage of births is from women 25 to 29. 30 to 34 is close to it, 28% of all births. It looks like 0% of births for a couple categories. But if we go down to 0.1%, it becomes a little clearer, right? That it wasn't 0%, it was just rounded that way because we only did the whole number. Here we went to the nearest tenth. More accurate. And so here, it's now clear that 25 to 29-year-olds, right here, have roughly 5 times as many births as 15 to 19-year-olds. So 5 times, that's about 6, a little less than 6, is a little less than 30, which is 29. So these women had 5 times more births than this category of women. So the table's nice and the pie chart's nice because we can get at comparisons like this. Now, how do we get at those? How do we get these numbers? How did these numbers come about? Right? Like I said here, we're going to compare the number of births in each category to the total number of births. So we're going to fill in this table. We're only going to do a couple. We're going to fill in some of this table to show you how this is working, right? Now this is different. This is the rate per 1,000 women of this age group. That's a whole lot different than asking the question, what percent of births were due to 10 to 14-year-olds? What percent of the totals? This is 100%. This is the total births. This means here that there was 104.3 births for every 1,000 women that were aged 20 to 25 to 29. Completely different. I should have put that up. So when we add up all these percentages here, it's going to equal 100%. So let's start with the ratio of 2,503 births for just under 4 million births total, one to the other, and that's 10 to 14-year-olds to total births. 10 to 14-year-olds to total births. There's your ratio, 10 to 14-year-olds total births. And you want to change the ratio and scale the bottom number to 100. So cross multiply and divide, and we get that small number, which is over 100. So it's way less than 1% over 100. It's 0.06 over 100. And we can interpret it to mean that the number of births of 10 to 14-year-olds in 2005 was 0.06% the number of total births. The pie chart rounded it to 0.1% up above. Now we're going to compute the percentage of 15 to 19-year-olds. Repeat the same procedure. That's the number of births from 15 to 19-year-olds divided by the total number of births, and we want to scale the bottom number to 100. Cross multiply and divide, and we get 5.79 over 100. And the way we interpret that is for 15 to 19-year-olds, the number of births was 5.79% of the number of total births. The pie chart rounded it to 5.8%. So now we're actually going to calculate a couple of these. We have a couple already in here, and we'll calculate a couple of these. So here we're going to calculate the percentage of total births for the age group 20 to 24. So you might want to hit pause anytime here and see if you can do that, okay? Here's the total births. Here's 20 to 24-year-olds. Okay, so I'm going to pause this myself and put in the answers, and you can see. So there's the ratio that we're working with. 20 to 24-year-old total births, some number over 100. We're rescaling the bottom number to 100 to find what percentage the birth number is of the bottom number. So we're going to cross multiply and divide, and actually put that up this time. Might want to hit pause and see if we can get the correct answer. So there's the worked out answer. There's the one ratio, and we're trying to find what this ratio is equal to in parts per 100. Cross multiply, and then divide by what's by the x, because 3 million and that over 3 million, this number here is 1, so it cancels. So x equals 21.398%. Actually could put that in there. And of course we could do the rest of the same way. Now, therefore we know the following ratios are equivalent. I just want to talk about this for 1 second. Hopefully you know that 1/2 is equal to 2/4 from our work in chapter 2. And this is just reinforcing what this is equal to. So I'm going to put up the 20 to 24-year-olds over the total. So there I have the 20 to 24-year-old total births of 20 to 24-year-olds over the total amount of births, and that's equal to what other ratio? In the same way, 1/2 is equal to 2/4. And from looking up here, you should know what this is going to be. That. So that's what we did. So how can we interpret this? We can interpret this to mean that the number of births for 20 to 24-year-olds, which is that number, in 2015 was 21.398%. .398 of the number of total births. 21.398% of the number of total births. In the pie chart, they rounded it to 21.4%. Yeah, this is important here. Hopefully you can see that the pattern we established and why the task is perfect for a spreadsheet. We don't want to do all these all one at a time. All right, to review, in this section we focused on rescaling the ratio to have the bottom number, thing 2, equal to 100. Scaling the bottom number, thing 2, to 100 gives us a percent. We work with both part to whole and part to part ratios. So here is one of the above. This is what we got, right? If we finished this with the spreadsheet or by hand, we would get this. Each group is part of the whole. This is part of the whole, part of the whole, part of the whole, part of the whole. Each group is part of the whole amount of births. We also learned that when you add up all the parts of the whole, you get 100%, which would make sense. You add all these up, and you're going to get 100%. Because there's nobody else that was given, it wasn't 60-year-old men giving birth, right? These are all the possible people, realistically, that can give birth. So that's the whole. We also learn a pie chart is a good way to display data when we're using part to whole ratios. Now here is a flip. This will be the last video, it's short. But often we're given a percentage and the amount, the whole amount, must find a part. That's a little different than finding the percentage. Now we're going to be given the percentage and we got to find what part that is.